All right, welcome everyone and hello, and welcome to today's Parks After Dark webinar. This presentation is being recorded. Participants are in listen-only mode with cameras and microphones disabled. My name is Jennifer and I am the park interpreter in Spruce Woods Provincial Park, which resides on Treaty 1 territory, home of the Anishinaabe, Dakota, and the Métis Nation. Over the course of the webinar, if you have any questions, please type them in the Q&A box and we will strive to answer as many as we can. Manitoba Parks is committed to promoting a healthy dark sky by reducing light pollution and providing stargazing opportunities in provincial parks. Over this season, we are offering a series of webinars with our wonderful partners at the Royal Astronomical Society of Canada. And today we are joined with our good friends, Sylvia and Jerry. We are here to learn all about sketching the stars. So please take it away, my friends. Just need to unmute yourself there, Sylvia.
Okay, can you hear me now?
Sure can.
So hi, Jennifer, and hi to everyone that's coming in tonight. And thank you, Jennifer, for inviting us to do this webinar with you. And welcome to this introduction of astronomical sketching, everyone. If you are hesitating, by the way, to draw because you believe you can't draw or you can only do stick figures, do not worry, because astronomy sketching is actually not about making beautiful pictures. Although after sketching enough, you will find that your sketches improve with practice, but that is not the point of astronomy and not the reason for sketching. And the reason for doing this is actually so much more amazing, and it actually has to do with working with your brain. And there are three major benefits of astronomy sketching. First of all, is that we become better observers. It improves your memory, and we remember what we saw. And we have a permanent record of our experience because at the end of our observation, of course, we end up with a sketch that we made. My favorite benefit out of those three is that it helped us become better observers. I have discovered so many things just by sketching stuff, and I was not a good sketcher either. So when we look at things, though, our brain is constantly trying to interpret and make sense of what you're looking at. So it hinders our ability to see what we are really, truly looking at. So when we sketch, you kind of have to have this little fight with your brain and separate what the brain thinks it's seeing and what your eyes think it's seeing. So basically what you want to do is sketch what your eyes see and not what your brain is seeing. Let me demonstrate what I'm talking about. Here we have a lunar sketch, right? And most of us would think, and this is how I used to sketch lunar craters at first, was circular, because we think they're circular patterns on the moon. But the truth is most of the lunar craters are actually polygons, and they have actually pretty straight walls. And look at this, you can see it here, straight edges. So right there, we're purging our brain of its idea that lunar craters must be round. Here's more examples of craters, and look at these straight edges. This one's a little bit more round, but then it goes straight again into polygons. Same thing here. And here we have the planet Mars, right? So planets, of course, are spheres. So we're going to draw a circle when we see a planet, right? But actually, no. Here's the planet Mars as it is in its gibbous phase. So not the full face of this planet is actually fully illuminated by the sun. And here it is as it is fully illuminated by the sun. Can you see the difference? And something that I like to do is play spot the difference game. This used to come in our newspapers, these little games, and you probably played them before. And here's one of those games where it tells you, there's 5 differences in these 2 pictures. And I can tell that one of them, for example, this one has 2 stars. And right here, it has 3 stars. So really, after you're looking at something and you put it on paper, what you want to do is ask yourself, okay, is what I'm seeing in the eyepiece the same as what I have just sketched? And check for differences. It makes you a better observer. So just recently, I was just sketching my favorite crater. It's called Eratosthenes. And I was spending a lot of time doing all of this and all of the things around it with these squiggly mountains and all of these artifacts around it. And then I had extra time. So I thought, you know what? I'm going to put in this nice, simple chain of mountains. It's the Apennine Mountains on the moon. And when I started sketching it, I couldn't believe the drama that I was seeing at my eyepiece on the telescope. I saw height on these mountains. I saw canyons with really tall walls and a little tiny crater on top of that wall, and then more mountains that just hid into the shadow that was on the moon. So it turns out that now my favorite part of the moon is not Eratosthenes, it's the Apennine Mountains. And I can't wait until it's positioned this way so that I can sketch it one more time. And then, of course, it's memory. Sketching something on paper enhances your memory retention. Had I not sketched all of these details on this very simple sketch, I would have forgotten a lot of those details, and they would have started fading away. So next time you think you can't sketch or that your sketch is ugly, because look at how simple this sketch is, think of it as a super tool. Sketching is a super tool that you will use to learn and see things as they really are. So when I look at this, I just did it on one of my little pocketbooks. It was in Pinawa, Manitoba, and I wish I had taken down more details. And that's what we're going to learn about sketching. This was about 10 years ago, but I didn't write down details, so I'm not sure when it was. But I remember the spruce trees, and all of this that you see right here was the aurora, and it was spiking right here with a little cloud going in front. Two airplanes were meeting in the middle, and I remember the constellation of Perseus and the star Capella with the little kids here on the side. And it just takes me back to that moment. Had I not sketched this, that would have been long gone. Here's another one where I was actually sketching the constellation of Scorpius. Again, a very simple sketch, right? But it takes me right back to that time when I sketched it. When we're in the Northern Hemisphere, we can actually only see this part of Scorpius. And this part you can see from the Southern Hemisphere. So I remember flying over Manaus, Brazil, and I sketched this out of my airplane window. And again, it takes me right back to that moment. It's just amazing how that happens. Galileo also sketched, and Galileo actually sketched the planet Saturn before humans knew that the planet had rings. So can you imagine? He couldn't imagine what was going on there. So he thought, okay, here's the planet. And I think I see two spheres, he must have thought. And here we research what Galileo would have been seeing on Saturn in 1610 when he did this sketch. And so he probably saw the sphere of Saturn. And then these sides of the rings, he probably thought, oh, those must be spheres. Then he also did it again in 1616 when the rings of Saturn were actually open to planet Earth. Here's a couple of sketches that Jerry did. And the rings are open to observers on planet Earth. So that's why it looks like this. But, you know, sometimes I think like, okay, why did Galileo sketch this? Is it because his telescope was really not that advanced and so he couldn't see it? Or was it because he wasn't looking with his eyes and he was looking with his brain?
One of the differences that happened over that time was his telescopes were more powerful. The early ones were only 20 power, which is really tough to see detail with. Mm-hmm. So he might have been stretching the limit of his eyes to resolve details.
We need to get a replica of this little telescope. I think somebody in the Astronomy Club must have one. And we should look at Saturn.
Scott Young.
Scott Young? Anyway, so yeah, we should test that out and see what was Galileo really seeing with this little telescope that he had. Although, right, having this little telescope, now that we know that Saturn has rings, it won't be the same comparison because Galileo didn't know and we know. So here's the brain, right? Again, filling in.
That's right. When we look at Saturn now, we know to look for things like the dark edge of the part of the ring that's facing us versus the part that's going to be behind the planet. So with us, believing is already seeing. We know what to look for. So we're not going to be quite in the same position that Galileo was, who was baffled by what he had no idea was what he was looking for.
That must have been something crazy. He must have been wondering what's going on that planet.
And it wasn't until at least 20 years after Galileo died that Christian Huygens actually saw Saturn well enough to sort out that it was a ring system.
And you asked me to upload this picture for you.
Yeah, I wanted to make this comment about sketching. This is perhaps historically the most famous sketch ever done. And as you can see, It's really bad. I mean, it's just a circle with a couple of asterisks next to it. And what you're seeing in each of these things is different days on which he was observing Jupiter. So this would have been December 30th in the year 1609. This was January of 1610, the 3rd, the 4th, the 6th, etc. So he was able to plot the position of Jupiter and what he thought were stars that seemed to wander around Jupiter. And by making enough of these observations, very crude little sketches that allowed him to describe so easily what he was seeing, he was eventually able to say that, yeah, guess what? Not everything goes around the Earth. Some things are going around Jupiter.
Right. So what he thought was stars was actually Jupiter's moons.
That's right.
And that's what he had proved. Okay.
Which we now call the Galilean satellites.
Awesome. So like Rosalina says here, remember, everyone starts somewhere. So again, here you have these simple sketches and you don't have to explain very much. She is telling us that Saturn was in this position with the rings oriented this way. Doesn't have to explain it with words. We can look at it and know exactly. Here's the planet Jupiter, where she was able to see some bands across the planet, and the 4 Galilean moons that we were talking about, and also the planet Mars. And these are the features that we're seeing on the planet Mars on that day. And there's notes to accompany this, which is great. And I don't know if you got a chance to look at Mars this summer, but it was on close approach to Earth. So we were able to actually see a lot of details. And there are so many cool sketches of Mars out there. If you want to look at them later on, do a little search on the internet. So yeah, these are simple sketches, but they reveal very interesting information. Here's one of our Winnipeg astro sketchers, Davidian Chorley, sketching the planet Jupiter. So he was able to see some bands on the planet. He saw, some clouds on the poles of different colors, and a barge. A barge is just a dark area that's crossing in the band, and some festoons as well. He also saw the moons, the Galilean moons, the 4 of them, and he put in some nice compass points and some notes, not like I forgot to, right? It's so good to know when this happened and what instrument he was using. And you can also make this a more complex sketch. So this individual, his name is Howard Banitch, and I found this sketch on the internet. And he said that this sketch took him days to do. So hours at the eyepiece, at the telescope, and then and on many nights. So over many nights he did this. And what he did was he sketched it on white paper with black pencil. And then he took a picture of it and inverted the colors. And this is something that's so easy. And look at how realistic it looks just by doing that action of flipping colors, which you can actually do on your computer, and your phone will probably have that feature as well. So it's called inverting colors. Here's one that I did myself of Comet Wirtanen in 2018, and I took some more notes. I learned my lesson. Here's the cluster of the Pleiades and the comet, which, you can see a coma and a nucleus really nice and bright, but no tail, because it was really, really dim. I used a very small telescope, but I was able to pick up some of those details. And I remember, when I read my notes on here that it says 60-kilometer-an-hour wind, I remember that I had to protect myself and be behind a wall to be away from the wind. Here's more sketches. This one is by one of my favorite astro sketchers. His name is Alex Massey, and I can't remember if it's Australia or New Zealand. Where he's
down
from.
Under someplace.
Down under. And he's so great at doing this. And he's doing here a nebula with some stars behind it. And he uses so many different techniques. So now you're wondering, okay, what tools do you need to do this? And by the way, I hope you have paper and pencil with you tonight, because we're going to do a step-by-step. And we can do it together. So the tools that you need are so simple. You just need white paper, you need a pencil, an eraser, a pencil sharpener, and a blending stump. You also will need a light. And if you're outside sketching dim objects, anything other than the moon, you're going to have to cover your light with red paper so that it doesn't ruin your night vision. White light will ruin your night vision, and you won't be able to see details on some of the deeper objects like Saturn. And by the way, I decided to use this paper as an example to show you how terrible I can be at sketching at first. It takes so long for my brain to get the idea of Saturn. So I did this and then this weird ring around it. And then here it is. And this is actually representative of what I saw at the telescope. And the amazing thing about sketching is that once I got it right, I got this 3D picture in my head about what I was looking at. I was even able to see a shadow on the planet, just very lightly casted on the rings. So it's just amazing what you can discover. Now, if you want to sketch the moon, all you need again is the same tools, and you can just have a book light to be outside. And the reason that I sketched the moon here in black is because I love inverting the colors, and look at how realistic it looks. I inverted the colors, and now whatever was black is white, and what was white is black. And something that I really liked that night about the moon was the earth shine. So earth shine is really light being reflected from the sun on the earth onto the moon. So if you were on the moon, you would be seeing earth shine, just like when we're on earth and we see moonlight. So how cool is that? So you can create a template too. There's so many of these online. So so that you don't forget to fill in the blanks, right? What object were you looking at? What date was it? What was the temperature, the telescope? You can even add extra notes. And this circle here represents the eyepiece at the telescope. And to sketch items into it accurately, you can imagine the face of a clock. So you can say, okay, at the 12 o'clock, there was a star at this altitude, or maybe down here, another one at the 9 o'clock, and you get the idea, right? Here's a sketch by Jeremy Perez, another one of my favorite astro sketchers out there, and he's doing a sketch of the galaxies M81 and M82. So again, you would picture in your mind the face of a clock and plot in here, 12 o'clock, you have the bright stars. Make sure you put in your bright stars first, and then the dimmer stars, and then finally, you locate the galaxies. Now, to put these stars accurately, because this is what you want to do, it's not to make this beautiful or anything, but you want to be as accurate as possible. So you can imagine triangles. So besides having the face of the clock, you can also imagine a triangle. So you're going to sketch this, and you see how you have this type of triangle, and then imagine another one, and then here, and then put one above. So you kind of get them accurately plotted in place, and then you add the galaxies. So to do galaxies though, you don't want to use a harsh pencil. That's when that blending stump comes in handy, because what you do is you put the graphite on the side of the paper on a separate piece of paper, grab your blending stump, pick up the graphite, and then add it ever so lightly onto your galaxies to add those really subtle markings. And you can tell that here he's going to end up putting an arm of the galaxy, and the center of the galaxy has a lot of graphite. And then when you flip this, you end up with these, the nucleuses being really bright and prominent. This galaxy is a little bit more lumpy, and you see how he added little lumps markings on here. So constellations. So for the beginners that tuned in tonight, constellations are basically groups of stars in the sky that form patterns. And people all over the world in ancient times used stars to form their own patterns. So everybody had their own pattern. And what we use the most here is Greek mythology. So we use patterns such as Ursa Major, which in Greek it translates to big bear or great bear and little bear. And you can see that the Big Dipper is just part of that. Now, what an odd bear is this? It's got this long tail, right? So I'm not sure where this bear came from. But indigenous people of North America thought that this group of stars was more like a fisher. And a fisher, it has a long tail like this, and it had the little legs, and it seems to be more realistic to me. And here's the Little Dipper, the little bear, or Ursa Minor. They saw it as a loon, and it seems to be an accurate pattern like that. And if you're wondering what a fisher is, because I wasn't sure, I thought that doesn't really look like a fish, but a fisher is a weasel. It's from the weasel family, and this is the cute little animal right there. So the Big Dipper is not a constellation. A Big Dipper is called an asterism, and basically an asterism is just a simple recognizable pattern of stars. And this asterism just happens to be part of a constellation called Ursa Major. So the cool thing about the Dipper and why we chose to sketch the Dipper tonight is because It actually is very useful. If you ever want to know where north is, all you have to do is use the pointer stars of the Dipper, and that would be Dubhe and Mirach, these two stars. Count this distance 5 times, 1, 2, 3, 4, 5, and you'll end up in the vicinity of Polaris, which is the North Star. Polaris is not the brightest star in the sky. What's cool about Polaris, again, is that it points north and it never moves from that position. It's always in that same area, and everything seems to rotate around it. The reason for this is because the axis of the Earth points to the star Polaris. So, and to see what this is, to illustrate this, what you can do is look up at something in your ceiling. You can look up at your light, for example, and spin on the spot. And you'll see that the thing that you're focusing on the ceiling stays still while everything else is moving around. So it's kind of that same thing that's happening with the star Polaris for us. So very useful. And here's an animated illustration to show you. Here's Polaris staying still in the sky in the north with everything else going around it. And here's the Big Dipper. So here it starts again. You see the two stars that point to Polaris, and the Big Dipper will just go around it every 24 hours. Everything will just go around the North Star. And I thought I'd share tonight a picture of my friend Sheila Wishar, who is an amazing astrophotographer, and she took this picture of the aurora. And I noticed that the Big Dipper was in here. Here's the handle. Now I know it looks really hard to see because there are so many stars where she lives. There's no light pollution. And when there's no light pollution, you can see so many stars, but you won't have this trouble in the city because you won't see that many stars. And that takes me to the effects of light pollution, because the cool thing about light pollution is that it's so easy to fix. All you have to do is, well, you could turn your lights off, or you can have a motion sensor on your lights. So when you're not using them, they actually shut off. The other thing that you should do with your lights is put a shield on them. So instead of having light spilling out into the sky and washing out all our stars, you have the light where it's supposed to be, pointing down. The other thing that you should do is close your blinds at night and make sure that it's blinds that doesn't allow the light from inside your house to spill into the environment. And this is actually a picture by Michael Vlasov, and he took a picture of the Andromeda Galaxy when he was in dark skies, so with no light pollution. And here's another picture where he was in the suburbs, so close to the city with a little bit of light pollution, and you can see how you can start seeing less details of the galaxy. And here, finally, you are in the city with hardly any stars to be seen. So it's a shame, really, because it's so easy to fix the light pollution problem. So the other thing that we chose the Big Dipper is because it has a lovely surprise in it. It has a double star that you can actually see with a naked eye. You don't need a telescope, you don't need binoculars. And here's the Big Dipper that I actually sketched on white paper again and inverted the colors. And here's the handle. And here is the bowl. And if you count 5, it'll take you to Polaris, right? And here's the lovely surprise of Mizar and Alcor, the double star.
What about the comet?
Oh yes, we had a comet this summer, which I hope that you all got to see, Comet Neowise, and I sketched it into this sketch as well. Here's a picture of the nice double. This is Alcor, a smaller star, and here's Mizar looking bigger. And if you look at it with a small telescope, you're going to be amazed to see that actually Mizar is 2 stars. So you will split Mizar into 2, and Alcor will continue to be 1, although that's also a double. And scientists told us that if you actually were to be able to see the Mizar group, you would see that it's a set of binary systems orbiting around each other. Like, how wild is that? So it's actually a group of 6 stars that we're seeing, with Alcor and its double, and then Mizar and these binary groups. Now imagine being a planet going around this system. Like, how weird would that be? You would have so many suns. And this is an artist's impression, of course, but how cool would it be to have, or not cool, but maybe for a holiday.
Could be quite hot.
And if you're on that planet, you would have a sun rising here and a couple of other suns on the side. It would just look so weird. it would always probably be light on it. Like, would you ever have night on a planet if you had stars all over the place illuminating it?
Yeah, depending on the orbits, you may never see darkness on such a planet. That inspired a consideration like this, inspired Isaac Asimov to write one of his famous short stories called Nightfall, about a species that was terrified about the idea of what's going to happen when all of its stars are on one side and they finally get to see darkness.
Wow, what an idea. I want to see that story.
That's really good.
Yeah, because for once, if your stars lined up, you would actually have nightfall. And what would that be like for these beings? I mean, if anyone can live on this planet. So that takes me to our event of the night, which is to sketch together the Big Dipper. So I hope you have some paper and a pencil ready. And I'm going to switch the camera now. I'm sure nothing will go wrong with this.
Right.
I'm going to switch the camera and I'm going to sketch the Big Dipper, and you can follow along, okay? Okay, so it looks like it's working. So the first thing that I'm going to do, I'm going to start by sketching this star right here called Doobie. And you can kind of see that Doobie is different than the other stars, by the way. Do you notice that it's got a little tinge of color? So it's a red giant, which means it's far along in its life, and it's probably going to end up being supernova one day, but not for a long time. So let's start by putting in Doobie. And these are fairly bright stars, so the more pressure you apply on your pencil, of course, the brighter you end up with a star. Next, let's put in Mirage. And again, let's just make sure that we're accurate. It's a little bit of an angle there, and something like that. Then you go down about the same distance, but a little bit longer than that. And right underneath and a little bit scoot over to the left. Then again, on a little bit of an angle, you sketch another one and go under. See, this is what you make a comparison with. Go right under Doobie, but scoot a little bit over. Go right by Fecta and go a little bit down. So this is not going to be perfect, but you want to be pretty accurate as possible. This star is called Migres. And the way that I remember its name is by calling it meager, because it's so light that sometimes you can barely see it in city skies. So next, we're going to go on an angle like this, about the same distance that we just did, and put another one. Go up a little again. It almost seems to be on that same trajectory, but a little bit higher. And then down a bit. And here's where you can imagine those triangles. You see how this is a flat triangle? And there. And now we added Alcaid. Now, the lovely surprise, of course, of Mizar and Alcor, this is a double. And you're going to see Alcor right about there. Now, the other thing that I do is I play that game, right? Okay, spot the differences. And I think this is pretty accurate. Maybe Alcor should have been a little bit closer to Mizar. And then I'm going to do the magnitude. I want to make sure that Doobie is brighter than the rest of them, because it is the brightest one. So this one is not as bright as Doobie, but right. So this is going to be almost the same as Mirage. Migres is going to stay a little bit lighter. And here we have another brighter star. This one's called Elias, and it's almost the same as Doobie. Same with Merak. I'm gonna make it bigger, and look, that corrected my Alcor distances. It wasn't so close, and now it's perfect. And let's make Alcaid the same. So now you have a pattern of the Big Dipper, and the other thing that you should do is do this to find the North Star, because that is so useful for people to know. So grab the pointer stars, which is Doobie and Merak. You'll always remember because Doobie is orange. So go go this distance 5 times. So 1, 2, 3, 4, 5. So the North Star will be right about here. Now let's switch cameras again. And there we are. So hopefully you had enough time to do that. And like I said, don't worry about what it looks like, because That's not what's important. Just try to be accurate. And when you go outside tonight, you're actually going to see the Big Dipper in this exact position. So go looking at the northeast, and you'll see the Big Dipper standing on its handle. And look for the second star from the bottom and see if you can spot that double. And then practice finding the North Star. So then you can't get lost, right? At least in the nighttime when you can find the Polaris. And now let's move on to the constellation of Orion. So Orion's constellation is actually something, it's a hunter. And this hunter was actually seen all over the world because the shape of it actually does resemble a hunter. Here's his shoulders. Here's the belt. This is a famous trio of stars that you're probably familiar with because they're so bright and they're 1, 2, 3 in a row. Here's the sword, and we have a knee and a foot here. We also have a shield, and all of these stars are actually visible from the city. And actually, if you had a really sensitive camera, you would be able to see this large molecular clouds of dust and gas around this area of Orion. And there are so many of these amazing features here, but we're going to look at one of the most famous, which is the Great Nebula in Orion, which is actually a star nursery where stars are born.
Yeah, a stellar nursery is where most stars are formed. Most stars don't just happen to be singles. They are born in large swarms out of these giant cold molecular gas and dust clouds. And you end up with clouds that condense to the point where little gravitational knots will form, and then you'll end up with stars starting to get so compressed that they can finally ignite their nuclear fuel and fire that way and start glowing. And once they're able to glow, the stellar winds off of each of these stars will start to blow off all of the excess gas and dust. So these will eventually result in what we call open clusters of stars. So all stars at this point are formed out of these huge clouds, and then you end up with a swarm of stars that will eventually scream loud enough through their solar winds to drive off all of the gas and dust, and you'll end up with a star cluster, which over time will disperse and be flung around the rest of the galaxy, and the way our sun was 4.5 billion years ago.
And this is something that you can think about as you're sketching. Consider all of these amazing things that are happening. And talking about star clusters, the Belt of Orion is actually a star cluster. There's hundreds of stars here. If you were to look at it with binoculars or with a telescope, you'd be able to see a lot of them. I think it's called Colander 70, right? Mm-hmm. It has a lot of stars. So this is probably a familiar sight for everyone, I hope. And so here's the belt with the 3 stars, 1, 2, 3. I decided to take a picture or use a picture from the internet of a city sky because this is really what it's going to look like. So if you're to go out tonight and look south, you will be able to see Orion tonight. So, and the easy way to spot it, of course, is the 3 famous stars of his belt. Here you have the star Beetlejuice, and then Bellatrix, and you have Saiph and Rigel. And here is the sword. So the shoulders, and I believe this is the head.
Yes.
So the shoulders, and here are the knees and the foot and the belt. So we're going to go ahead and sketch this tonight too. So I'm going to switch cameras so that you can see what I'm doing. Okay, and the way to start is, let's start with these brightest stars again. So this is the star Beetlejuice. And you're going to see also that Beetlejuice is a really orangey star. It's another red giant that is at the end of its life, and it could be turning into a supernova. So let's sketch it. Nice and big because it's one of the brightest of them all. And maybe you want to make a little note, check for color and make comparisons. Scoot right across, and let's put in Bellatrix, which is about the same brightness, but a little bit smaller, I think. And then we put in the belt, and it forms a waist. So go inwards, maybe about here, and we put 1, 2, and 3. So you can see it's inside of the shoulders. And then to make sure that we're in line to put in Rigel, one of the tricks that you can do is follow from Beetlejuice. Sorry, thank you. Follow from Beetlejuice and draw an imaginary line like this and go to about outside and put in Rigel. So you see, you can kind of compare it like that. It should have been actually going in more.
Yeah.
So you can fix this, and this is where you are going to make those little adjustments as well. And then with the other side, to put in Saif, you do the same thing. It's actually kind of like this. So I'm making the connection from Bellatrix
Through the middle of the belt.
through the middle of the belt. Thanks, Jerry. So, and that's what we're going to do. And it's just outside. Looks like about here. And then we're going to put in the sword. And this sword, the middle star, is actually where you find the great Nebula of Orion. So consider that when you're out there sketching. And we can put this other one. You see how there's one on the side here? And here's the great Nebula of Orion. And this star too, because you're going to be able to see it no problem out there. And I think I got them all.
Yep, good enough.
And the other thing that you can do, now that you kind of sketched it in, is make those corrections. For example, like, I put this one way too close, so I might want to make those corrections. And then do the magnitudes. You want to compare them all. How bright is this one compared to this one? That kind of thing. How bright is this one compared to this one? And make sure you get them all nice and right. And now we're going to switch chairs, and I'm going to switch the camera. Oh no, should I leave the...
You can leave that up for a bit.
And I'm going to change cameras. There we go. Okay, let's switch up.
Am I on the camera here? Okay,
Yeah.
looks good. Okay. Stars aren't the only thing you can sketch. There are many other objects in the sky. There's clusters, there's nebulae, and of course there's planets. And planets are bright and easy to find. And so we thought that we would include a quick little primer on sketching planets. Here is a couple of views of Jupiter. The view on the left here is a really good image by an amateur astronomer of the planet Jupiter that he took. And over here on the right is a sketch done of Jupiter, obviously at a different time. You'll notice that there's some very bright, obvious dots on this image. And this is not any kind of goof up or any mistake. What's happening here is that a bright moon is transiting across the surface of the planet from our angle, from what we can see. This is called the moon's transit across the disk. This black dot is actually the shadow of this moon. And over the course of several hours, you'd be able to watch it drift across the face of the planet and go across. So you can watch an eclipse remotely this way. If you were to be flying in Jupiter's clouds in this spot, you would see an eclipse of the sun by this moon. And notice how the moon seems to be quite bright here. By the time this moon would move on to the planet, it may not be quite so visible, but these shadows, they're like bullet holes, and most amateur telescopes are capable of showing this kind of event on this planet. So while you may not see all the detail that this very nice image portrays, what you see in this sketch is quite close to what a really good image of Jupiter would be like. And that's another advantage of sketching, especially in astronomy is concerned. Too often now you see the fancy glossy magazines that show you the beautiful colored pictures of celestial objects. We usually don't get to see them that well. what we usually get to see is something much closer to what the sketchers give us. And so in some ways, the sketch can be more informative than the fancy image can be. And to make that point even more blatant, here is a picture that you might see on any given sort of poor night of observing. The telescope can't magnify the image of Jupiter all that much because the seeing conditions are pretty lousy, and you can barely make out the bands on the planet and see just variations in its brightness. But all is not lost. You still have a view of Jupiter that's much better than Galileo's original one, and you can plot the positions of the moons. And this is a great fun little exercise we do at public outreach sometimes, where we get the kids to plot in the positions of the moons. Because if they're dedicated enough and want to come back in a couple of hours to check it out, you will see that the distance between these moons changes even within a few hours. So it's a never-ending parade of images that you can have looking at Galileo's moons that circle Jupiter. Now, here is going to be the image that I chose for us to sketch. This would be a wonderfully great detailed image for anyone to try sketching. And first off, don't be too intimidated by all the fancy detail you see in there. We're not going to worry about trying to capture every little nuance of this, but this is a more entertaining sketch to try because of the amount of detail. And this also has one of those events where the moons of Jupiter are also included, and we just happen to have a shadow falling on the planet. Now, I was going to play the game of, well, which moon do you think caused the shadow? But it would take too much of a agonizing story to go through it all. But one of the things to recognize when you're looking at planets is they aren't always the obvious, simple circle that we think they are. Just like craters aren't simple circles, neither are the views of a lot of planets. For instance, when you look at the planet Jupiter, you'll notice one thing about this one. It is not round. This distance is shorter than this distance. It's a squashed circle, an oval. And this is due to Jupiter's very fast rotation. When you're looking at Jupiter, what you're looking at is the clouds. It's mostly all gases and such in the outer parts of Jupiter that you're seeing. You're seeing the cloud tops here. These clouds spin around once every 10 hours or so. So this actually causes the planet to bulge out a bit at its equator as it spins round and round and round. So the first thing to recognize when you're going to sketch Jupiter is it's probably not going to be round the way you might have assumed to begin with. So your template that you make for Jupiter might be a little bit different. The other thing I wanted to point out before we go to the sketch is to talk about the way in which you're trying to determine what the sun angle is. For instance, we've got two candidates here, two moons that might have been responsible for this shadow. Now, the question is, do we have any clues to help us as to which that might be? Well, if you know enough about celestial mechanics and know the positions of the planets, you'd be able to sort it out. But you can get something from this view alone. If you're a careful observer, you will see that this limb of the planet on the right-hand side is relatively defined and just has a very quick, abrupt drop-off a bit in its detail. The left-hand side here has a more gradual drop-off, and this edge is not quite as defined as this one. The reason for that is you're not seeing the exact edge of the planet here the way you are here. What's happening is you are far enough out of line of the sun so that you can start seeing the terminator line, the line between the light and the darkness. the same way we see on the moon all the time. So this terminator line, this fuzziness here, is going to allow you to say, so this is the side that the shadow is showing up on. That must mean the sun is shining at it from this side over here, shining down onto Jupiter this way. So my guess would be this is the moon that's causing that shadow. If you were still in doubt, watch the scene for about another half hour or so and watch which way everything is moving, because this shadow and the moon causing it will move in the same direction. So if this moon is moving out this way, that shadow will move with it, and you'll be able to sort it out from that. So, okay, we need to switch views here, and we can start the sketch.
I'll switch the view for you.
Okay, now the first thing we want to do is make a circle of the planet to start sketching in. Yes. And so what we usually do is just find a nice round object to do that. You could use, for instance, this cup and make a round Jupiter template. But we know it's slightly off of that. So a really easy way to cheat on that is to use something like a cup, but just squish it in slightly and then trace around that. And I always can't get my pencil all the way around, so I have to fill it in. Maybe you're more adept at working with cups than I am. There we go. So now we've got a bit of an oblong Jupiter to work with. Now, the first thing to do would be to get a scale of where to put those moons. And it seems to me that if you look at the sketch, the distance from the center of Jupiter to the edge is slightly more than from the moon to the limb. So if I know my distance from the center of Jupiter to here, I know my moon is going to be slightly closer than that. So maybe my moon would be about here. And then we do the same on the other side, and you'd see that it looks slightly lower down than this, but closer. So this other moon might be found over here. Now, one of the big differences in sketching planets is going to be that we're not going to worry. Not yet. They can still see.
Oh, right. I'm sorry about that. Yeah.
Okay, so if they can see this image, what's going to happen is with the other images, we use that trick of inverting things. We're not going to invert when we sketch our planets. At least we usually don't. So what we're going to do here is dark things are going to be sketched dark and light things are going to be sketched light. So the first thing is the most obvious dark thing to sketch, which will be the shadow of the planet. And as you can, of the moon, right? So here's the moon here, and it looks like it's just slightly lower, and it's slightly past the middle of the planet. So we'll put it about here. Nice, dark bullet hole of a shadow. Wow, very lumpy. It must be that famous potato moon. Okay, good. Then we've got the major features of Jupiter all drawn in here. Now, one of the tricky things is to try and get the proportions right on where to put the bands. So again, what you can do is sort of measure from the center and realize, if I was to do it on the planet, if this is the center here, halfway to the pole would be at about this faint band. So halfway between my dot and the pole, we'll put that faint band in. And we're not going to worry if it's too accurate or not yet. A little bit up above it, proportionally so, is this darker stuff here. And then it's kind of fades and fizzles into the edges. almost always when you're looking at planets, you'll notice that all around the limbs of the planet, as you can see in this image, it fades out, it gets kind of fuzzy. And then you just sketch in all the darker material at the top. And then you want to plot the two major bands. And they come close to the center. The north band is usually the one that's a bit darker. And again, Sylvia and I had this discussion earlier where she almost always sees color in these. I don't always see color, but I do see color fairly often. The darker of the two bands is usually got a lovely brownish color to it. And then the other band is
brownish orangey, I would say.
Okay. And the other band is more streaky and not quite as misbehaved and runs across the whole planet here. And if you make too much of a defined line near the edge, that's okay. That's what your eraser and your blending stump are for. And I see I've kind of got this a little bit out of control here. And you could just sketch it in this way. There's another small band right below it here. And then the darkness of the polar region. And you can sort of fill it in. If your eyes were good enough to actually see these little white ovals that are found right here, sketch them in. It's very difficult to see those ovals unless you've got very good seeing and your telescope's power is cranked right up. And then just fill in the rest of the details as such. And so now you're on your way to getting a pretty good sketch. You've got the basics laid out here, and now you can worry about the details, such as putting in those lovely festoons that are reaching in off of this band here, etc. There's a couple of equatorial dark areas, darker area here in the band. And then you do, as Sylvia suggested, do the comparison back between the image and your sketch. What's different? What's missing? Until you have it all sorted out that way. And in just a few minutes here, we've got a decent sketch of Jupiter. So hopefully you can, if you could have followed along with your pencil and paper and done your own sketch. And here is the planet Saturn. And we decided we're going to try and include it too, because it's just such an impressive object to see. This is a amateur's image of Saturn, and you saw some images of it earlier in different configurations and such, but it is a showpiece object in any telescope, even small telescopes. This planet alone is probably responsible for more people being amateur astronomers than any other object out there. It is really that impressive, even in small telescopes. And one of the things that people don't always recognize is, depending when you're looking at Saturn, you're going to see it with its rings at different angles. Because Saturn, like Earth, has its axis pointed to one part in the sky, and yet it's orbiting around the sun, depending where it is in its orbit, we may be looking at the rings partially open, or the rings almost edge on, or the rings fairly open. And depending on the year, to go from edge-on rings to wide-open rings is 7.5 years. So you'll get plenty of opportunities to see each over the course of time. Then they get to wide open, go back to closed, and then the other hemisphere opens up again. And that's one of the things that you'll note in your sketch. Where does the ring go across? And where does the ring go behind? Notice in this sketch in next year, this is how it's going to look, with the ring going in front on the lower part and behind on the upper part. But by 2028, that situation will be reversed, and the ring in front will go across the upper part. Okay. And again, you may not always get the best views and the steadiest of nights to allow you to get super great views of Saturn. So you can also do with Saturn what you do with Jupiter. And hopefully on your screen, you'll be able to see these little points of light. These are 5 of the moons of Saturn that are visible in small telescopes. So you might have chances of seeing these moons and plotting their course. Unlike Jupiter, where it's a regular event where the moons go across the face of the planet, with Saturn, because it's usually got this tilt, and you can tell the tilt from the planet, there you'll have the satellites going around it rather than across it. So here is our Saturn for sketching. And you could go through, do the same thing. It's a little bit squat as well. So if you were to do a sketch of Saturn, you'd want to squish it in a little bit. It's hard to do on this, but I'm just going to get a rough sketch in here because we're running out of time. And there's my lumpy Saturn. The first thing to do is to recognize how much further out the rings go than the planet does. So when you look at the planet, from the center to the edge of the planet, that distance is about the same as from the edge of the planet to the edge of the rings. So however much you have on your sketch of this distance, the edge of your ring should be about the same distance out. So I'm just going to make a crude plot of it this way. So the edge of my ring should come out that far. Then you want to know how high up they go. And these don't go all the way to the pole, and then they would arch around like that. And then it would come across and be sort of symmetrical. And notice, one of the first things you'll want to do is make sure that you've got the ring passing in front of the planet in one case, and don't draw the ring across this other part. That would be a no-no. So you don't want that to happen. The next thing to do is to see if you can plot the inside edge. And if you look on this picture here, it looks like there's this fuzzy little bit on the inside. That's real, that's really there, but you may not see that unless your telescope is large and your seeing is very good. So you'll probably end up plotting something along these lines, maybe even a smaller amount. And notice, again, this is where sketching is going to help you so much. Notice how the ring doesn't have the same width. When it's at its furthest point from the planet, that's where it's widest. It's actually quite narrow across this part here and not very wide across this part here. So you'd have it wider here and narrower across here. And it's just a perspective on that kind of thing. Then if you have a chance, you could sketch in Cassini's division. You probably won't even see it all the way around. This is an excellent picture and we'll get it. Then you'll also want to draw in any bandings on the planet. And you'll notice that the bandings on the planet, or anything that's happening at the poles, and there's usually something fun at the poles, the line that this makes is going to follow the curve of your rings, because these are all basically circular objects being looked at an angle. So you're going to have the...
And here's the curves. I remember when I did Saturn and I thought, oh, something is wrong with my Saturn. And you pointed out that I had done my bands straight across.
Yeah.
Like in Jupiter, which is not the case with Saturn.
Mm-hmm. So yeah, we didn't take much time to do this because we're sort of running out of time, but I wanted to just get that across as far as the idea.
Shadow too.
That, oh, right. Yeah, thanks for that.
Such a cool thing, that
right.
shadow.
And as you can see in this image, you can see the shadow that the planet is casting on the ring here. So this tells you all kinds of information. For one thing, it tells you that Earth is on this side of the line between the planet and the sun. If we were on this side, we would see the shadow on this side. We don't, so we must be past opposition. At opposition, when we're directly in line, you won't see the shadow either way.
All right, so we're ready. You can scoot over a little bit. Don't worry about the camera anymore.
Okay.
We're gonna switch the camera here. Okay, and there we are. So basically, everybody, sketching is really a connection to the cosmos. It really draws you in and it gives you a more intimate experience because you're sketching it in. So it's not like you're looking at one object and then moving on to the next. So there's the Belt of Orion and there's Jupiter and Saturn. It really draws you in. You really have this intimate experience, right?
Yes, and as we have picked for our last sketch, something that's very, very famous, Van Gogh's painting of the Starry Night. In one sense, this is a very bad sketch. I mean, in some cases, it's not very accurate at all. But in another way, it's a very important sketch because it's trying to convey the observer's impression of what he saw. And although I just finished calling it a bad sketch, in some ways it is not that bad a sketch. People who were so enamored with this wonderful painting were able to go off and do things like take a look at the position of the moon in the sky, take a look at this bright star here, which is actually the planet Venus. They knew where he was in certain towns, and this information alone was enough for archaeologists of history to determine when and where Van Gogh actually painted this picture. So even something that can be totally impressionistic can still contain data that's valuable for doing things such as dating events.
That's amazing. That's a beautiful picture. And you know, something I learned over the years is that, yeah, it's important to make sure that we're as accurate as we can, right, when we do our sketches. But most important of all is that you get out there and you look at something, observe your universe and give it your undivided attention and take in that sketch so that you're paying all of that attention to that item and celebrate this endlessly wonderful cosmos that you have by sketching your experience. So, and with that, we are closing off this sketching session, and I hope you enjoyed it.
Well, thank you, Sylvia and Jerry, so much. I greatly enjoyed this. I have learned so much. I'm not even going to show my sketch, but I did sketch with you, and I really, really enjoyed the program. So if anybody happens to have any questions, now is your time to comment in the chat box, or you can put it in the Q&A. We don't have any questions at the moment, but I also have to mention earlier that my favorite animal in the entire world is a fisher. So the fact that you had that our indigenous peoples use the fisher as the Big Dipper, the Ursa Major, is like fantastic for me. I find that really unique and neat.
The tail is the right length.
The tails.
Tails don't have long tails.
It's a fisher. It is a fisher. That's what it is.
Yeah, it's a fisher.
So I'm just going to thank you guys so much for coming and joining us today. We really appreciate you taking the time to share your knowledge with us on astro sketching. And if anybody at home would like to enjoy astro sketching, we really encourage you to head out to any local provincial park or even your backyard with a pair of binoculars or a telescope. Or, as we learned, even just your eyes if you need to.
Exactly.
Yeah, and it's a wonderful time to get out and do stargazing because it is getting really dark out in the evenings, and we've got a beautiful aurora going on. So of course, just keep in mind, you can also download various stargazing apps on your smartphone or tablet like Skyview or Stellarium or Starwalk. And when you do visit provincial parks, just make sure that you do follow COVID-19 public health orders. Make sure you're not gathering in large groups and practice the fundamentals of physical distancing and wearing a mask. Be sure to sign up for our other webinars and online events for Manitoba Parks. The next one is all about going batty, where you're going to learn all about Manitoba Bats, which is occurring next Saturday at 10 a.m. Details and registration info is available on our Manitoba Parks Facebook page or online at manitobaparks.com. So, yeah.
Come check us out at the Royal Astronomical Society.
Yeah, so join, like I love this up here, join and contact the Royal Astronomical Society at www.winnipegrask.rask.ca. That's wonderful. Thank you guys so much for coming and doing this wonderful program. I really, really appreciate it. Thank you so
This
much.
was great. Let's do it again. Bye,
Yeah,
everybody.
absolutely.
And remember, you can contact us at the Winnipeg RISC if you have any questions.
Right on. Thank you, everyone. Have a wonderful, wonderful evening. Stay safe.
Take care. Bye, everybody.
Bye.